Okay, so today I'm talking about how the year was in terms of where we had failures in the code in the project. So bugs that either we introduced in the year or that became apparent in the year. And at least one of them has kind of been with us for some time, I guess. So um, the rationale for actually talking about this, as you can read off the points yourself, I think the one of the things would really like people to be able to help us out with would be actually diagnosing these problems. A lot of these things you do need specialist hardware to look at, but a lot of the time that specialist hardware isn't all that expensive. So actually um, uh, um, maybe getting people more involved in debugging this project, these um, these issues with us might be one of the things we'd hope to get out of this meeting, this presentation. Um, so there's kind of two categories of bug which we've divided these into, and they're failures in that we should have foreseen in the code or that have been introduced into the code. And there's the other sort of failure is where we've failed to take into account just how shoddy hardware can be to us sometimes. So stack overflows and other memory corruption, definitely things that shouldn't sneak into our own code. Um, these are the sorts of things that easily crash vehicles. So the things we have to be particularly careful of. And to a certain extent, unfortunately, we've kind of let things slip a little bit because one of the chief tools that we use to find this sort of thing, Coverity, actually kind of failed halfway through the year, and we didn't take that seriously enough and get in and actually get it fixed. So um, as you see, both the issues mentioned there were found by users rather than ourselves, which is not the best way of doing things. Um, on the bright side, some of the mitigations we'd put in place for previous uh, uh, failures actually helped us out here, even though they weren't original. In particular, the Watchdog reset was put in place for hardware failures where we failed to take into account a particular failure scenario, and ArduPilot's blocking up hard, so we introduced the Watchdog reset. Further mitigations for Stack Overflow include stack logging, where we proactively check how much of the stacks that we allocate for our threads have been used, and if that gets beneath a certain, if the amount of free space on the stacks gets beneath a certain threshold, then we should probably consider that to be a critical failure of the code, since we should always have some margin on those stacks. I should point out that we're after input from everybody on the call today about how else we might go about diagnosing these failures and perhaps instrumenting the code or adding features to the code to detect some of these things. So, for example, the STM32 has various hardware features which might help us track down memory corruption issues. In particular, setting hardware watch points on memory may allow us to detect these things at runtime as they occur, rather than proactively checking the stacks periodically. Those hardware watch points might also be useful during diagnosis to help us know to narrow down the point of failure faster. So I guess I could just ask right now, does anybody have any ideas on how we could do better in terms of preventing memory corruption and form stack overflows and array overruns and the like? If you can drop any ideas into the chat, perhaps, that might be a good way of putting things forward. So other common form of memory corruption, buffer overruns. Thankfully, this one didn't get out into any stable releases, so there weren't any need to re-release our stable binaries. The last point on here is that our choice of implementation language here is kind of the primary reason we have these things. C and C++ are kind of renowned for having this sort of problem with them. If you were to go to implement an ArduPilot system again, you may not choose to do so in C or C++. You might choose kind of an equivalent level language, but one with stronger memory protections. So this one took Tridge quite some time to track down. It only came to our notice, in fact, when a user noticed by ear that their rather large quad plane, if I understand, was having some motor problems. You could actually hear it if you were paying attention, and he was paying attention and brought this to our attention. Took Tridge some time to find it out, work out what this was, but it was on the OMCU, too much CPU usage, and it caused the motor to stutter. These things are very difficult to track down, particularly on the IOMCU. Having a richer communication interface between the IOMCU and the main flight controller might actually make this a little easier to track down, perhaps. So that's something we could look at doing this year to try to make these things more apparent and easy to debug.
Yeah,
so these are the ones.
Sorry, just on that last one there, Peter. With the the output timing, whatever the IOMCU issue. For me, like it really took a. I mean, one of the wonderful things about ArduPilot is we have so many users, and when you start getting these little comments from people, once you hear it once, think, okay, maybe just a one-off. But then once you start hearing it from like 3 or 4 users in slightly different contexts, you sort of realize, there is something. So for me, this one actually, this IOMCU bug, you just hear these little murmurings coming out, every few weeks from the users. I don't know. I guess I'm just saying, yeah, it would be nice if we had a more definitive way to track down bugs sometimes, rather than relying on the community. Although the community, certainly, I think, let us to know that there was a problem.
Are you thinking of a better way of collating information on a problem? So, for example, at the moment, often we get issues raised. That's by far not the only way we could track issues. We could use an issue tracking system or something along those lines. Is that what you're referring to?
I didn't really have much of a concrete point to make. Just that I guess in this case we relied. It took us. We were really relying on the community to uncover this bug, and I guess that's sort of like the last line of defense. When you have whatever tens of thousands of users, there's going to be a user who's going to uncover almost every single problem, and probably multiple users will uncover every single problem. I guess I was just saying that I wish that we could find it another way before it hits the last line of defense. I think everything gets caught by the last line of defense pretty much. Otherwise, it's not really a problem if no user experiences it. But if we had maybe like hardware testing, I know we've talked about it in the past, and it's really, really hard to get organized, especially considering all the different types of hardware that we support. But if we had like a hardware setup that would test everything and look for differences, I'm not sure exactly how that could be done, but that might help uncover some of these problems.
The problem we're looking at here, where a motor starter, that would, even if you had a comprehensive hardware test setup, it's hard to think that it might catch this sort of thing.
Yeah, I agree. I think the only way to caught this was if if we had an oscilloscope attached to if we were very specifically testing the timing of the output between versions. I think that's the only way that we would notice the problem.
Well, what you could do is loop back the outputs back into the ArduPilot's inputs and just measure the PWM input and do your, as I said, we probably wouldn't have detected it. We could certainly add a regression test for it if we had a hardware test setup, but it's doubtful that it would have prevented the problem from happening in the first place. The high CPU load, on the other hand, is something we could detect and feed back potentially to the main flight controller.
Yep.
So, that's definitely something we could detect, and that might be the root of other problems as well, of course. Logic bugs kind of cover things that are kind of entirely internal to our the ArduPilot logic, and these are the ones that kind of really ought to be preventable. A lot of these could have had a regression test written for them before the code was significantly modified, so that we ensured we didn't have regressions.
Sorry to interrupt. I was wondering, are we missing the FR Sky issue? Is that in there? For me, that was one of the other very serious. The FR Sky send text, I think, was the other one that was sort of crash-o-matic and led us to rush out another patched release.
It is possible I've missed one. I basically went through the release notes for the last year and looked at all the ones that we listed as being serious issues in the release notes. So
it was certainly in a previous draft. It does seem to have dropped off the list here.
Right. And the other one, sorry, just for completeness, the other one that didn't cause crashes but caused weird behavior was the EKF home thing, right? The EKF home altitude, EKF origin altitude being set to.
I didn't include sort of just weird behavior ones. I didn't include just the weird behavior, and I wanted to have the most serious, the ones we've sort of put a safety bulletin out about, linking back to the sort of safety bulletin idea from James and Stephen earlier today. So I tried to keep it down to just the most serious of issues, because obviously, there's lots and lots of small bugs that we have, and some of them are some of them are quite important, but they aren't crash-o-matic, as we call it. These ones, although some of these ones I do have listed didn't actually ever cause a crash, but could have caused a crash. And some of them did actually cause crashes and did lose vehicles.
Yeah, there's actually another one on here as well. The notionally the play tune bug that we currently have, which I believe my pull request is still outstanding for. Notionally that is vehicle falls out of sky bug. It's just you'd have to use the Mavlink play tune command to have your vehicle fall out of the sky. So it's bad, but you do have to really work at it.
We probably wouldn't do a safety bulletin for that one because it's such a obscure and really self-inflicted issue that I don't think we'd bother with the safety issue with that. But obviously it should be fixed.
So how do we prevent this sort of logic bug from I think these are basically have to be code review. There's very little you can do apart from code review. Some of these we can prevent by having a suitable auto test for them. So, for example, the using EKF origin in place of home for Copter's current location, that was actually caught by an auto test. It's just that the auto test hadn't actually been committed to our repository, so it didn't actually get caught in testing. And subtle enough difference that that bug survived in Copter for a ridiculous amount of time for something so fundamental. But again, we could have actually prevented that. And in fact, it's now prevented in the future because we have an auto test for it. Defining the behavior we want in auto-tune is, I believe, still an outstanding issue. But once we've decided how we want gains to work in auto-tune, that is to say, in the middle of in an auto-tune, if you want to stop using the gains, how do you stop it using the gains? Or start using the gains, how do you get it to start using the gains? When we save the gains, if we can actually decide how we want things to work, then we can nail that stuff down so that when somebody next refactors auto-tune, we don't get a regression. So checking your return values, fairly basic sort of a programming thing. Sometimes when you don't do it, you get bitten, and it costs significant amounts of developer time. I might point out that a lot of these bugs have taken a significant amount of developer time to track down. Tridge has spent days tracking down many of these bugs. So this one we can help prevent by adding more compiler flags. So we have gone through our code base and added quite a few annotations to various functions to say that the return value for this must be checked. We should, I think, go through and actually annotate more functions. I wouldn't be surprised to find that simple action might actually find some fairly significant potential for vehicle loss.
Yes, it was actually inside the Shibios code that we had an unchecked return for an allocation. And so we wouldn't necessarily notice in our main repository. But yes, we should probably mark those as, requires checking of the return value. I've forgotten what the particular tag is. But yeah, I do think expanding the number of functions where we require return checking would be very worthwhile.
Especially since it's, there's no runtime cost for this. The worst you get is where a caller, you look at the caller and say, yeah, I really, really, really don't care what the return value is. And that just gets a little bit nasty because you've got to cast the result away or annotate it as, no, I'm really answering.
You can have a macro to do that. You can have a macro that says we ignore return. This particular one was quite a humorous bug, actually. The key to eventually tracking this down was, it turned out that he got corrupted logs, but the log ended up just containing multiple copies of the NuttX bootloader, which was really, really bizarre, given we were no longer using the NuttX bootloader. And it's because it was just referencing the start of Flash, where we still had the old bootloader installed.
I think the most amusing thing of that was Tridge actually recognized the bootloader.
Yes, the binary of the bootloader. I thought that looks familiar.
Which is a bit disturbing, frankly.
Yes, that was quite funny. Yeah.
So that brings us on to the second category of bugs I mentioned earlier, which are the ones that, they're really not our fault. This is where hardware just isn't behaving itself as it should. And we have failed to appropriately take into account that hardware is awful to us. So the worst case, in my opinion, was the top one here, which was the I2C lockup bug. Which caused a flyaway for us locally here in an area where you really don't want flyaways. So the ArduPilot locked up solid. We didn't have the watchdog. We got watchdog as a result of this incident.
Break it.
The plane actually behaved much as if an RC radio receiver had not been configured for radio failsafe, and the transmitter had just ceased to exist. So constant motor output, constant control surface output, and the vehicle was just that well set up and was in such just the right throttle level to continue flying until the battery ran flat, which took it many minutes, 15 odd minutes, I think.
Yeah, something like that.
So
yeah, it had a significant dihedral on the aircraft, and it was perfectly trimmed by ArduPilot, so it basically just flew with absolutely no changes in the actuators or the motor, and it just locked solid. It flew for many kilometers.
So I believe Tridge dug out a test rig that it had for a previous I2C problem and managed to recreate it, which is I think an electric drill with wire wrapped around it.
Yeah, this is something where we could consider having, when we change to like major RTOS version, that we have a series of hardware tests we go through where we do things like inject noise into the I2C bus. Because we had that set up previously. It's sort of an embarrassing bug, as we had hit this bug previously with NutX and fixed it. And we tried to apply the same fix in Shibios when we did the port, but we didn't actually run the hardware test where we injected the noise. And it turned out that the fix we applied wasn't complete. And so that was really just, in our rush to get across to the Shibios, we didn't run that hardware check. So we really didn't do our due diligence there when we're changing, I2C hardware driver and not validating that it's immune to noise. So that obviously has been done now, and our releases, it's all fixed. And I hope the last of those I2C bugs is gone. But it was easily the worst bug that we've had for a long time.
Yeah. Next one is is much more recent. This one only got resolved, I think, week before last. Might have been last week. Again, significant quantities of developer time tracking this one down because it wasn't kind of where we're expecting it to be. One of the chief problems with this is that it took a long time for anybody to pop up with a repeatable test case, but then somebody did, and that got things moving again. This one was basically the Ramtron driver that's used on many of our boards for persistent storage. Was left in a state after a reboot such that noise could cause the Ramtron driver to completely reset its storage. So this just eventually was just a relatively straightforward patch, I think, to the bootloader to pin a pin to a particular high or low, and the problem went away. So that one was basically a reproducibility issue. As soon as we had a reproducible test case, it was a lot faster to track down, I think.
Yeah, still took a week or more, maybe even a week and a half working with that user who could reproduce it before we actually narrowed it down. So it took, probably the longest time of any of the really major bugs that we're talking about in this talk, more than any other.
Yep. And then we've got the IME failover bug. So we had the unfortunately this kind of should have been part and parcel of the first one, where if you have a sensor cease to exist or cease to give you data, then we should use an alternate sensor. Unfortunately, we kind of missed that that bit, so we were failing to fail over to another sensor.
We did fail over. There was actually multiple stages to this bug, and it shows a failure in our processes, because we were actually failing over the sensor in some parts of the code, but not in others. But more importantly, when we did fail over the sensor, we weren't handling the biases after the failover. And that's something where we did a very quick validation flight after fixing this bug, and the validation flight went okay. So we didn't just say it's all fixed, we pushed it out. If we'd done a few more validation flights, we would have realized it wasn't actually sufficient. And we do actually need to learn the gyro biases for the inactive gyros. So that was an example of us not doing sufficient testing on a bug fix. We only did fairly cursory testing, and that meant we had to then do another bug fix later, which really fixed it properly. So our processes for validating fixes like this, particularly the more complex fixes, needs to be more careful.
I did actually want to talk about things that would add to the code to help with validation as well. And one of the things we added to track this sort of thing down was the ability to fail IMUs in flight. It's something you want to know you're doing, but you don't always have a piece of faulty hardware you can fly. So adding things to the code where you can fail bits of the software, so you can do that for IMUs, and we can do that for GPS, for example. So what can I suggested said earlier that we're after ideas for how we can prevent this sort of bug in future, both regressions, which we certainly had from when we moved from Nutex to Shibios, we had a couple of regressions. Those I think we might be able to perhaps document, so that if we do choose to change from Shibios to something else in future, we can go and make sure that things we've addressed in that layer of the software get addressed in, or at least make sure we're not going to have the same problem in the next layer next piece of software we use for that layer. We are in the process of trying to get a couple of positions funded for code review, so people can do in-depth review of the somewhat more detailed review that Francisco was so good at, that might have prevented some of these things from creeping into the code. The fact that we let Coverity stagnate for 6 months since May last year, I think it was, isn't great. I'm thinking that perhaps we might want to move that up to running weekly rather than every month. It will mean people will probably want to filter those messages out of a normal reading, though, if we run it too often.
Peter, sorry, when you say it stagnated, do you mean that it broke and stopped working, or do you mean that like people stopped looking at the output?
It stopped functioning. So Tridge and I started to
well, both actually. We also stopped looking at the output. We didn't notice that it had stopped updating as well.
Yeah. Actually aggressively trimming out all of the stuff that we've looked at and determined not to be a problem might help with keeping people more interested in the Coverity output. Michael in particular, I think, was the person who looked at that stuff the most and kind of raised the issues when he spotted something of consequence. But we probably all should have been paying a bit more attention to the output. But yeah, it just wasn't being run.
And it still isn't being run now. We've tried to trigger it again, and we've failed to trigger it. Michael pointed out that I stuffed up the branch the other day, but I've restored that, and I've fixed up the path to the compiler because it was using the old compiler, which isn't available on our download site anymore. So we've fixed that, but it's still not triggering. And so we need to either keep looking into that and work out why, or start using a different static analyzer. I wouldn't be surprised if there's another option than Coverity now, which may do a better job.
Yeah. So if anybody knows of any static analyzers we should look at.
Are people aware that Clang stack analysis just works with ArduPilot? You can run that locally easily.
That's a static analysis, or is that a?
No, it's static in Clang.
Right. Okay.
I've used it and actually fixed some stuff from it before.
Right.
So
okay.
Could we have that run as part of CI, Michael, with sufficient whitelisting of problems it finds?
I'd actually say almost, I mean, yes, we could put that in CI, but in some ways it's almost better as auto test because it actually generates, what the output from that is actually a set of HTML that you can browse. So if you put that on the auto test server, you could actually have a continual list of the problems it's found.
CI means they don't get in the first place if our whitelist is good enough.
Yeah, I haven't looked at what the whitelisting part of the output looks like. I've always just explored the web interface, but I wouldn't be too surprised if there actually was a nice programmatic output somewhere.
The problem with auto test is that nobody seems to pay too much attention to it. So until I looked at it again about 3 weeks ago, we're passing about 13 of the 28 tests. So it's looking a bit healthier now, but it's still not right. It's still 25 and 28 or something where build binaries is failing, and a couple of other tests, all fixable, but just takes time.
Yeah. I think that really comes from once it starts failing consistently, then people just turn off and say, oh yeah, it's just an expected error, and so then nobody looks at the output anymore. So yeah, just getting auto test so that it reliably passes is really key, I think.
Well, what you said earlier about Michael's doing a bulk of the work on that stuff. I wouldn't mind chipping in on that. That seems like something that's worthwhile if we could somehow get to a 100% completion on those. I think it's I'm not sure if it's achievable, but we could at least get some more eyes on that.
Yeah, the main problem with Coverity is just that it doesn't handle the newing thing correctly. You're supposed to be able to upload some override files, and last time I tried it, wasn't accepting them for some reason. I need to go look because that actually might be part of the problem with the current analysis.
Is that a limitation of like the free version that we're using?
No, it's Coverity generally struggles when you start overloading, because basically Coverity does its analysis by trying to overload stuff like new and free. So it got upset that we did that because it doesn't know that that means the memory is zeroed. So that's the majority of our false positives. And the problem is you can flag them. I've done that in places. But as soon as somebody rearranges that little bit of code, then the warning pops up again. So you have to kind of flag it again.
Is it worthwhile to look at any other static analysis tools?
Well, there's one I would recommend. The problem is we might have to end up paying for it. But there actually is a tool that does stack checking. And it's actually based on GCC. So I think it actually probably wouldn't be too hard to get it to work with our stuff. But that's a very specific, that's a stack check only tool.
Well, I mean, if we have money to pay for such a thing, it sounds like it's worthwhile to do. It's not too much.
Yeah, I'm not sure what it is. It's probably one of those request pricing, but they also actually publish an open source version of the compiler, so we might be able to get a nice price.
Does it work on embedded or only on x86 and similar?
It's actually a highly aimed at embedded, so it actually might work for us. I haven't checked. So it's NatStack is the tool I'm referring to, and that's from Ada Core. It's part of their NAT compiler suite, which is the GNU, Ada toolchain, whatever. But that's actually part of GCC. So they released their own, pro support version of that. NatStack is a non-free tool, non-open source, but because it's all based on the GCC toolchain, I actually don't think it'd be too hard to get that going with ArduPilot.
I don't see NatStack on Google much. There's NATSTAK or STACK?
GNAT.
There we go.
So I don't know. There's probably some effort to see if that actually would even work for us, but that is one that might help us with the stack type checks, because that's going to compute the worst case bounds.
Which is good for us to know. I mean, that gives us good, at least.
It's
wow,
a good starting point.
It runs in C++ and Ada.
Yes, that's what I know, because I like the Ada side. The only real risk with that is it is a good starting point, and it's going to be similar because it's still GCC based. But unless you're actually using NAT or the free software version of NAT, which does compile for ARM, but unless you're using that, you're going to be looking at a slightly different output. So unless like we might be able to make our current GCC compiler give us the intermediate form that NatStack needs to ingest, in which case it's perfect. If we have to use a different compiler to get that, then the stack usage is going to be a little bit different than the real boards. It's still indicative, but it'd be a little different. And if we're willing to potentially pay for it, I'm happy to chase up with them and see if we can get pricing in a demo.
Yeah, definitely. Definitely chase it. They might be willing to give us a really, really good price, and if it's going to be of use to us.
Yeah, and I might be one of those ones where, well, you're open source as long as you like write up an article that talks about how it fixed something, which we'd be happy to do.
Stack usage, just doing the automatically, showing an error in Mavlink if you get within some threshold of stack usage, that's probably going to find stack usage problems pretty quickly. And if we then log the stack usage per thread, because the last stack usage problem we had was the one where it only mattered if you had Mavlink signing on. And I really don't know how those static analysis tools are going to be able to cope with that.
Yeah, but that's something that's hard to catch in the simulator, right? Because the stack is totally different.
The tool is going to compute the absolute worst case stack. So your most likely problem actually is that it's going to be too pessimistic.
Yeah.
Because it's going to explore every code path at the same time. That's what we want. So I agree we'll catch a lot by flagging it, but I think there's a risk there that on the times where you're going to blow up, we're going to flag it right as we blow up. You have to have a huge margin so that, the times when you're flagging it, you're actually still safe. Because the signing one just kind of kept going. And same with the FTP one. It didn't just miss it by a little bit.
Michael, did you want to contact them or me? I can do it if you want.
I'm happy to follow up with them.
Okay.
So Tom, did you have a look at the Clang stuff, or?
Well, I don't know anything about Clang, and I'm not compiling for Clang. Can I do that on non-Mac OS?
It works just fine on Linux. That's where I did it.
Okay. How does it work on? I use WSL, so hopefully that means the same thing on that.
Yeah, I think it should work there.
Okay, quick question: is anyone running WSL 2? No?
He's running what 2?
WSL, the Windows
WSL.
Oh, WSL 2. No, not yet. It does look as though it's very promising. It should be a lot faster. But at the moment, you have to be on one of the bleeding edge Windows releases. So I haven't actually tried that yet.
Yeah,
but it looks like it'll be generally available fairly soon and be an awful lot faster.
Well, I think it's actually rolling out now to be not on the bleeding edge anymore.
I'd looked at it a couple of weeks ago, and it was still a matter of you still have to be on one of the Windows Insider Track ones, I think.
Yeah, but not the fast. It's like
no,
just
that's right.
Slow
but
or something else. But it
isn't yet generally available. You can, if you jump through some extra hoops, you can get it apparently. And I'm hoping it will make building on Windows enormously faster. I wouldn't be surprised if we get a 5 to 10 times speed up in building because the file system access should be an awful lot faster.
It's actually pretty good on WSL1. Surprised.
Well, not compared to running on native Linux. It's still order of magnitude slower.
I digress though, so let's not get too side.
Yep. All right.
I guess I'd go over down to the concept of a hardware regression suite now.
Well, hold on, Peter. You asked me about the Clang one. I don't know anything about Clang, but I can look into it if that's something that we need.
It's not just Clang, but rather the static analyzer, which is associated with it.
Yeah. I'm looking at that link you posted.
You actually do have a pull request in place to try to use it, I think. That's Clang ASAN, isn't it, Michael?
I do have a plan.
The problem with that solution was that it didn't understand our memory clearing. It didn't understand our new and free. And in fact, it actually overrides new and free. It overrides new and free itself, which leads us to do something very, very nasty because it doesn't zero the memory like we do.
Yeah, I did try the Clang. Actually, I've got a branch somewhere which adds an option to SimVehicle to launch it in CITL with Clang with ASAN enabled. Unfortunately, you've got to do an LD preload. But it didn't actually, at the time I was chasing the issue with going past the end of an array, and it didn't actually find that, and I was a bit disappointed. So basically, it will only find memory accesses that are outside of the current block of memory. So if, for example, you've got an array on the stack followed by another variable, and you access beyond the end of the array and get into the other variable, ASAN will not flag that as an error, which is disappointing. And in fact, I couldn't find any tool that would flag that.
Why didn't Valgrind catch that one, Dridge?
Well, Valgrind doesn't as well. So Valgrind, again, is memory block based, and it is a valid legal access in memory. It's just not part of the object. It doesn't understand the boundaries of individual variables. And I couldn't, there were some versions of like GCC2. There are patches to GCC2 that give you that, but there's nothing with current versions of GCC or G++ that seems to do bounds checking on arrays that I can find, which was quite disappointing. I was hoping that there would be a tool to do that.
Just a quick one, Peter. You're keep changing the screen you're sharing. I don't know whether that's intentional or not.
No, that's not intentional. Sorry about that. I was just looking for the I don't seem to be able to bring the. Oh, there we go. Chat. The pull request which somebody's got there for Clang ASAN support is 13235. So if you wanted to help chase things, Tom, that would be a.
It didn't seem to offer anything that was better than Valgrind apart from being faster, because it doesn't slow you down as much as Valgrind does. But I didn't find anything about what it will discover in terms of bugs that was better than Valgrind, which is why I just abandoned that effort, because it's a bit awkward to use because you've got to use an LD preload. You can't just use a normal link, and that's a documented problem with the way ASAN works.
Did Andy's PR there actually handle that preload?
I haven't looked at Andy's PR, but it certainly didn't work for me on Linux without the preload.
That's the pull request there. Okay, so we've only got about 5 minutes left. We should probably talk about the concept of a hardware regression suite. So several bugs have been tracked down eventually by replicating the hardware setup that causes the problem. So we had an example a few months ago now where somebody had managed to tie their GPS receive line from that is to say data from the GPS receiver to the one of the I2C lines, I2C data line. I think.
Yeah, that was actually Henry who managed to do that. And so after a crash, he managed to cross-connect his I2C lines and his serial lines from his GPS, and that's what actually triggered the last of the I2C bugs. And it was really good the way Henry was able to provide information on reproducing that, terribly useful. But that's the sort of thing that's very difficult to track down with a regression suite, because we can't randomly connect wires in our hardware regression suite. We can set up particular scenarios, but it's a matter of the effort in maintaining that hardware regression suite versus the bugs that it finds. And I suspect it wouldn't come out as a good balance.
For finding certain categories of problems, I think it would be invaluable. In particular, having a piece of hardware set up which we run, all commits that compile on, and gathers CPU usage, for example. That would easily help us find regressions in our performance, for example, and isn't going to be particularly subject to bit rot.
Yeah, that'd be worthwhile.
Assuming,
that'd be one that shows our scheduling misses and things over time. I think that would be, and that's an investigation I'm doing at the moment about the performance regressions that we've had. that would be something I think would be very worthwhile.
So I'm quite sure there are several tests we could do, which won't be specific enough that that they'll never catch anything ever again. I think there are probably going to be several that we can implement too. That where we've had regressions over time. Performance is just the obvious one, but you could also check free memory at boot, for example. Make sure that we don't suddenly lose a gob of memory because somebody's dropped a 0 where they shouldn't have, that sort of thing. Things like log download rate would be another one. About a year and a half, year ago, we discovered that the log download rate wasn't anywhere near what it should be. So we could just transfer logs between it and a dedicated computer and make sure that they come down at a reasonable clip, that sort of thing. That's a user interface, user-facing thing as well, and users were unhappy about that. So
yeah, it could be. I think that's a really great idea. I can imagine in a perfect world, in your PR or something, or in the auto test that's run against the PR, it tells you how much additional memory or your CPU it takes. That'd be kind of interesting. I'm not sure if that's even possible, but that'd be really cool if we had that.
Well, the ultimate thing after this is have hardware on standby that is on some server that runs.
Or the intermediate one is doing like chemo support and actually emulating like the STM32, which sounds crazy for the record. I know that, but I've actually been playing with that with some ADA projects here where it just worked. I didn't realize I was debugging the simulated hardware instead of the real hardware.
It's the peripherals. That's the hard part.
Yeah, you have to actually implement them.
Yeah.
So this actually does parts of them. It does actually all the registers correctly, but then you still have to implement the drivers to do the real other side of it.
Yeah, it's quite a lot of work. It's fantastic. You can get
yeah,
it all
exactly.
working, but it is a lot of work. The QEMU does that brilliantly for x86 machines, and I've used that quite a bit in earlier projects, and it was really nice. But I do think just having an old Pixhawk 1 connected on USB to a machine which regularly runs tests and logs performance stuff over time. The performance one is a relatively easy one to do.
I have a Synology disk station server, like a NAS that can just be connected to a cube and a GPS or whatever, and run daily builds or something.
All right, so we're running out of time for this talk. Thank you very much for this idea for a talk, Peter. Much appreciated. I think that's been some very useful discussion.